NEC 620.24 mandates that a separate branch circuit supply both the hoistway pit lighting and receptacles. This stipulation implies that these loads must operate on their own dedicated circuit, isolated from any other electrical demands. The rationale behind mandating a separate branch circuit is to guarantee the continuous availability of hoistway pit lighting and receptacles, even in situations where other loads on the circuit experience failures. This is critical for ensuring safety, given that the hoistway pit is inherently a hazardous environment where personnel may need to perform tasks or evacuate during emergencies. The prohibition against connecting the required lighting to the load side of a ground fault circuit interrupter, GFCI, is similarly intended to maintain lighting availability in the event of a ground fault. GFCIs are engineered to trip upon detecting a ground fault, which could consequently disrupt the power supply to the lighting if it were connected to the GFCI's load side. Therefore, the correct interpretation dictates that the hoistway pit lighting and receptacles must be powered by a separate branch circuit. This circuit should not be linked to any other loads and should not be protected by a GFCI. To elaborate further, it is essential to grasp the fundamental concepts of branch circuits, dedicated circuits, and ground fault circuit interrupters in the context of electrical safety and code compliance. A branch circuit refers to the portion of an electrical system extending beyond the final overcurrent protective device protecting the circuit. This overcurrent protective device is typically a circuit breaker or fuse. In the context of the NEC, branch circuits are classified based on their maximum permitted ampere rating or setting of the overcurrent protective device. Common branch circuit ratings include 15 amps, 20 amps, 30 amps, and 50 amps. Each rating is designed to accommodate different types of electrical loads. A dedicated circuit, as mandated by NEC 620.24 for hoistway pit lighting and receptacles, is a branch circuit that exclusively serves a specific load or a group of loads within a defined area. In this case, the hoistway pit. The primary advantage of using a dedicated circuit is its ability to isolate critical loads from potential disruptions caused by other loads on the electrical system. This isolation enhances safety and ensures reliable operation of essential equipment or lighting. Ground fault circuit interrupters, GFCIs, are safety devices designed to protect individuals from electrical shock hazard. They operate by monitoring the current balance between the hot and neutral conductors in a circuit. If a ground fault occurs, meaning that current is leaking to ground through an unintended path such as a person's body, the GFCI detects this imbalance and quickly trips the circuit, interrupting the flow of electricity. GFCIs are commonly required in locations where there is a higher risk of electrical shock, such as bathrooms, kitchens, outdoor areas, and construction sites. The NEC mandates GFCI protection in specific areas to minimize the risk of electrical injuries. In the context of NEC 620.24a, the prohibition of connecting hoistway pit lighting to the load side of a GFCI is based on the concern that a ground fault in another part of the circuit could inadvertently trip the GFCI, causing the lighting to fail. This could create a hazardous situation in the hoistway pit, where adequate lighting is essential for safety. Now let's delve deeper into the implications of each interpretation provided in the initial question. Interpretation asserts that the elevator pit lighting circuit is independent and should not be connected to any other lighting installed in nearby spaces outside the pit. Similarly, the elevator pit receptacles circuit should also be independent and not connected to either the pit lighting or any other receptacles. This interpretation aligns precisely with the requirements of NEC 620.24a. By maintaining complete separation between the hoistway pit lighting and receptacles and other electrical loads, it ensures the highest level of reliability and safety. If a fault occurs in another part of the electrical system, it will not affect the operation of the pit lighting and receptacles. Interpretation B suggests that elevator pit lighting does not require a dedicated circuit and can be connected to other lighting in nearby spaces outside the pit. However, it stipulates that the pit lighting should not be connected to receptacles in the elevator pit, and vice versa. This interpretation partially complies with NEC 620.24 by recognizing the need to separate the pit lighting and receptacles from each other. However, it falls short of fully complying with the code because it permits a pit lighting to be connected to other lighting outside the pit. This could potentially compromise the reliability of the pit lighting in the event of a fault in the shared circuit. Interpretation C proposes that elevator pit lighting and receptacles can be included in one circuit, while excluding other lighting and receptacles outside the pit from that circuit. This interpretation is the least compliant with NEC 620.24a. While it acknowledges the need to isolate the pit lighting and receptacles from other loads outside the pit, it fails to recognize the requirement for separate branch circuits for the pit lighting and receptacles. Combining these loads on a single circuit could increase the risk of overloading the circuit and potentially causing a failure that affects both the lighting and receptacles. To further clarify the importance of code compliance in elevator installations, it's crucial to understand the potential hazards associated with these environments. Elevator hoistways and pits are inherently hazardous areas due to the presence of moving equipment, confined spaces, and potential exposure to electrical hazards. Proper lighting and readily available receptacles are essential for ensuring the safety of personnel who may need to enter these areas for maintenance, inspection, or rescue operations. Inadequate lighting can increase the risk of accidents, such as slips, trips, and falls, while the absence of properly functioning receptacles can hinder the use of necessary tools and equipment. Moreover, non-compliance with electrical codes can lead to serious consequences, including electrical shocks, fires, and equipment malfunctions. In the context of elevator installations, these risks are amplified due to the critical nature of the equipment and the potential for life-threatening situations. For instance, a failure of the hoistway pit lighting during an emergency could impede rescue efforts and endanger the lives of trapped passengers. Similarly, a malfunctioning receptacle could delay critical maintenance tasks and compromise the safe operation of the elevator. Therefore, adherence to NEC 620.24 and other relevant electrical codes is paramount to ensuring the safety and reliability of elevator systems. This includes not only the proper installation of electrical components but also regular inspections and maintenance to identify and address any potential issues before they escalate into hazardous situations. In addition to the specific requirements of NEC 620.24a, there are other related code provisions that govern the electrical installation in elevator hoistways and pits. These provisions address issues such as wiring methods, grounding, overcurrent protection, and emergency power systems. For example, NEC Article 620 provides comprehensive requirements for elevator, dumbwaiter, escalator, moving walk, platform lift, and stairway chairlift installations. This article covers a wide range of topics, including the location and protection of electrical equipment, the sizing of conductors and raceways, and the installation of control and safety circuits. Furthermore, NEC Article 700 addresses emergency systems, which are essential for ensuring the continued operation of critical equipment and lighting during power outages. Emergency power systems are often required in elevator installations to provide backup power for the elevator car, control systems, and hoistway lighting. These systems must be designed and installed in accordance with specific code requirements to ensure their reliability and effectiveness. It is also important to consider the impact of energy efficiency on elevator electrical systems. Energy-efficient lighting, motors, and control systems can significantly reduce the energy consumption of elevators, leading to lower operating costs and reduced environmental impact. However, any energy-efficient modifications must be carefully evaluated to ensure that they do not compromise safety or code compliance. For instance, replacing incandescent lamps with LED lighting can save energy, but the LED fixtures must be properly rated for the environmental conditions in the hoistway pit, such as temperature and humidity. In summary, NEC 620.24 requires a separate branch circuit to supply both the hoistway pit lighting and receptacles. This requirement is intended to ensure that these loads are always available, even if other loads on the circuit fail. The prohibition on connecting the required lighting to the load side of a ground fault circuit interrupter (GFCI) is also intended to ensure that the lighting remains available in the event of a ground fault. Therefore, A correct interpretation is that the hoistway pit lighting and receptacles must be on a separate branch circuit that is not connected to any other loads and is not protected by a GFCI. This interpretation aligns with the overarching goal of the NEC, which is to safeguard persons and property from hazards arising from the use of electricity. By adhering to this code provision, electrical engineers and installers can ensure that elevator hoistways and pits are safe and reliable environments for both workers and passengers. Remember that electrical codes and standards are subject to change, so it is essential to stay up to date with the latest revisions and interpretation. Consult with qualified electrical professionals and local authorities to ensure that your elevator installations comply with all applicable requirements.